Hey guys, I've got a little video here for you to help you with your MathXL. A couple people are asking, so I just wanted to help you here a little bit. So first of all, remember, skew to the right, looks to the right like that, the tail goes to the right, and skew to the left, tail goes to the left. Okay, so number 3 on your MathXL, let's say you have a data set 1, 2, 3, 4, 5, 6, where the mean is, you add them all up, divide by 6, and you get 3.5. Median is also 3.5. How do I find that? Because, top, bottom, top, bottom, top, bottom in the middle, and the median's right there in the middle. The average of it is 3.5. Well, let's look at the new data set. So the new data set's 1, 2, 3, 4, 5, and 9. Okay, how does that affect the mean, and how does that affect the median, and by how much? Well, the mean, of course, I'm going to do the same thing, 1, 2, 3, 4, 5, but this time plus 9. So literally, I have added, instead of, which I didn't put here, this is going to be 21 over 6, which is going to be 3.5. But instead of 21, I'm adding on 9, it was 6, right? So I literally added 3 more. So now it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that's 21, right? 1 plus 2 plus 3 plus 4 plus 5 plus, and this instead of 6 is 9. So 6 plus 3 is really what it is, 9. Still divided by 6. Well, and then if I do the math, that's 24 divided by 6. So it's going to be 6, right? No, 24 divided by 6 is 4. Okay. Which is increased by 0.5. Well, let's see if I can just look at the increase. Look at here. What did I do? I increased it by 3, right? Because this went from 6 to 9. So my increase, my mean increase, is just 3 over 6, because that's what I increased it as far as my finding my average, which is 1/2. And if you notice, my old one was 3.5 and my new one was 4. So that's the way it's going to work. Okay, let's look at, because mean is a median. Let's look at our median. For a median, in this case, it doesn't affect it at all, because cross out here, and here, and it's still 3.5. So the median is a position. It's just the middle number, and so it's not as sensitive to if I just affect the outer one. However, I do want to show you if I have a new set, and let's say instead of 1, 2, 3, 4, 5, 6, let's do this. Let's change this 6 now to a 1. So I have 2 1s. 1, 1, 2, 3, 4, 5. So what I did was this 6 now changed to a 1. Remember, my old median was 3.5. What about my new median? Well, my new median, basically, look, 6 was on this side of the median, and I moved it changed to a 1 on the other side of the median. Remember, on this one, when it changed from a 6 to a 9, the median didn't change at all. The reason it didn't change is because that value was above the median to begin with, and the new value is still above the median to begin with. And the median is the position, the middle number, so it doesn't shift. But now the old number was 6, and the new number's on this side of the median. And so now let's try to find our new median. We cross it out, and now my new median is 2.5. It doesn't shift a lot, but it does shift by 1 position. So if the median is bigger, if the data that changes is bigger than the median, and the new data now is smaller than the median, then yes, the median does change. But if the data that changes is on the same side of the median to the new data, then it doesn't change the median. Same thing with the IQR. So I'm just going to show you how to find an IQR. So IQR, let's just do our same set. Okay, so IQR is Q3 minus Q1. So let's go ahead and find Q3 and Q1. So first of all, find the median, which we found that at 3.5. Now, to find Q1, what you're going to do is you're going to basically go 1 left to the median. So 3.5 is the median, so I'm just going to go to the left of the median, and I'm going to find Q1. Basically, I'm going to find the median of the first half. So that's going to be top, bottom, and that's Q1. So you see, and then same thing here, and that's going to be Q3. So IQR is just going to be, the IQR is just going to be 5 minus 2. Okay. So when you find it on a histogram, if you find it on a histogram, you can find the median on a histogram. You just turn it into a dot plot. Okay, so you just would turn it into a dot plot, and then you would find, you know, top, bottom, and you don't know, let's say this is 4, 8, 12, 16. You don't know what it is exactly on a histogram, so it's somewhere in here. You just know it's in this bin from 8 to 12. Okay, so on here, for standard deviation, so let me show you what standard deviation is. The standard deviation, in order to find the standard deviation, we're going to talk about that more on Monday, but I will tell you when the mean changes, the standard deviation also changes. Okay, the mean and standard deviation are going to be hand in hand. Okay, so that's all you need to know really right now, and we'll talk about standard deviation more next week. All right, so let me look at the next problem. I think that's all you need here. So the measure of, remember, when it's skewed, you're going to be using median and IQR. When it's symmetric, you're going to be using mean and standard deviation. All right, I'm looking here at this next problem on number 6. This is the same idea. And then also I do want you to see, I'll go ahead and go through the quartiles and everything on here, but I do want you to see this question help. Remember, these are really super helpful. The Help Me Solve helps you solve this problem, but be careful because it actually resets the problem. So if you're well into the problem, you don't want it to reset it. You can do View an Example, and View an Example will actually kind of walk you through how to do this particular problem exactly. So if you're not sure how to do it, it'll show you exactly how to do it, and it's really helpful. So let's look through here for your fences really quickly. Building a box plot. Let's just build a box plot. I know this is going to be a really simple box plot, but I'm just going to build a box plot out of my little data set that I have here. So this is my minimum. That's easy. That's my maximum. My median, remember, was 3.5. And then remember, I cut off to the left of the median and found this here as my Q1. Cut off here and found that this here is my Q3. So let's go ahead and then I also need to check for low outliers. To check for the low outliers, remember it's any value that is less than Q1 minus 1.5 times my IQR, which is Q3 minus Q1. Remember, that's my IQR. So my Q1 is 2 minus 1.5 times 5 minus 2. So it's going to be 2 minus 1.5 times 3. So that's going to be 4.5. So negative 2.5. So any number that's less than 2.5, obviously my data set has nothing less than that, so I have no low outliers. I want to check for my high outliers. For my high outliers, remember it's any number that's greater than Q3 plus 1.5 times my IQR. So I already found my IQR was 4.5, so I don't have to do that again, or 4.5. My IQR was 1.5 times my IQR was 4.5. So my Q3 is 5, and my IQR is 4.5, so that's 9.5. And so my highest number is 6, so I have no high outliers. So I am set for that. So my box plot is going to look like this. One is my minimum, so that's where my first whisker is. 2 is my Q1, so I'm going to have it there. 3.5 is my median, so I'm going to have my next line here with my box. And then 5 is my Q3. And then 6 is my maximum. Okay, so that's it, and I would label it min equals 1, Q1 equals 2, median equals 3.5, Q3 equals 5, and max equals 6. Let me show you really quick. If this was, let's change that. Let's say this was 10, because I saw that it's an outlier if it's above 9.5. And let's say that was 10. Then obviously this would not look like this. This would have an outlier 7, 8, 9, 10. Would have an outlier right here because of a fence right there. And this now is not my maximum. This actually would be kind of weird because I don't have any other data, because my next one down is 5, which is also my Q3. So this actually would just completely disappear. So if I had another piece of data, like let's say, I don't know, if I had another, let's say it just added a piece of data, let's say I had a 6 there. Well, this isn't going to be completely accurate with Q3 and everything now because I added an extra piece of data. But if that were the case, then I would keep the tail and the maximum. Okay. All right. I think that's good for, and so remember, this is called my 5-number summary: minimum, Q1, median, Q3, and maximum. So that gets us through most of here. As far as your median, excuse me, on, let's see, stem and leaf and split stem and leaf, you can, as far as the median on here, of course, you just do high, low, high, low, high, low, the same thing that we just did. Okay, and I think this is just some more practice on this that you guys can do. I'm just looking through if there's any others that you're really worried about. I think these are pretty good as far as just doing modes and things like that. And let's see what this one looks like. Histogram. Oh, histograms and which ones go to box plots. So it's going to give you, it's going to just start introducing you to that. We start doing that a lot more next chapter or two. And yeah, this is just kind of giving you some of the ideas here. All right, and I think that's it. I feel like I'm babbling now. Just, yeah, and we'll do more of these in class on Monday, because this here actually is your Monday's homework, which is standard deviation and things like that. Standard deviation, remember, means average distance from the mean, which I'll just show you right now, where let's say distribution A and distribution B. Let's say this is 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. Okay, so this one here has a larger standard deviation. The reason it does is because standard deviation means average distance from the mean. And so these data points you can see have because this is my average for around this area is my average, but you know that most of the data is spread out further. That's what standard deviation means. Most of it's spread out further. And these here are all close to the mean, so they're a little closer.